All right, so we're looking at absolute value functions. So the definition here, the absolute value or modulus of a real number x is the distance from 0 on the number line. We write the absolute value of x as these bars around x. Okay, now so if x is greater than 0, example, x equals 3, I just picked that as a random number, then the absolute value of this, x would just be the x value, it's 3. It's already positive, so it's what we want. But we then have, if x is less than 0, say -4, then our absolute value here is negative x, as in what we do is we go, well, negative bracket, -4, we multiply those negatives together, we get a positive, and we've got 4 here. So the algebraic definition is the absolute value of x is, then we've got these x bars. We break this into sort of two functions now, and for x greater than or equal to 0, we just say the value is x, but then if x is a negative number, we multiply it by a negative, so it becomes negative x. So the negatives cancel out and we get a positive. Or an equivalent definition is the square root of x squared. Now the equivalent definition is an interesting one because this is like we go square root 3 squared equals square root 3 squared is 9, which just equals 3. This one here will make more sense. So we have square root of -4 squared, which means -4 squared is -4 times -4 is 16. So we have square root of 16 equals 4, gives us our positive number, hence the equivalent definition. Now that's quite a simple concept. That's just talking about numbers. Like if it's a negative number, it's got to be a positive. This next one we're going to talk about is, I've got a function here. If f of x equals x times the absolute value of x, then the absolute value of x can be replaced by x when x is greater than or equal to 0 and when negative x when x is less than 0. So the interesting thing about this is if I was to graph the function x squared, okay, it would look like this. It would be a parabola, which we've seen before. Okay, but you'll notice here that when x is greater than 0, I can have positive x, so I get x times x, which is x squared. Perfect. For this value over here, let me use my highlighter. That's all correct. I've got the absolute value. I've graphed the function that I should have. Now, unfortunately, on this side, when x is less than 0, I've got, because... Now, I want you to understand that only one of these x's is an absolute value. I've sort of picked a bit of a weird one. And so by our definition here, x less than 0, the absolute value one had to be a negative. So we end up with this negative x squared, x times negative x squared, which means this bit's wrong. What actually has to happen is that parabola, as we use negative values of x, goes down like this. And that's how we would graph y equals x, absolute value x. Okay, now if you put that in your calculator, you should get the same thing. Now, we're going to jump down here to graphing more. So absolute values, graph of y equals f of x, and the input value is absolute value. So what this means is it means whenever we get to negative x values, we're going to put a positive in. So it means here that if you think about what we've sort of talked about above, your graph here for x is greater than or equal to 0. So I should maybe get rid of that line. So for x is greater than or equal to 0, the graph is fine, we keep that graph. But then for x is less than 0, which let's pick a different, this bit here, we have to discard that bit of the graph, which means this thing has to go. We'd go, see you later, negative bit, and we would reflect the graph of x greater than or equal to 0 in the y-axis. So that means this function here, if I'm going to graph this, now make sure you realize that the absolute value here is inside the function. Unlike this one where we're absolute valuing the function. So this means we flip, and I'm going to do my best to sketch this reflection, but we would sort of see, we would see this. Now, apologies for my drawing skills, but this bit here would be our y equals f dash of x. Let me write that a bit better. That's no good. So that's that function there, which is kind of cool. Now, that's how we graph this one here when we're looking at the absolute value is inside the function. This next one here, we're looking at y equals the absolute value of f of x. So we get the graph of f of x, or this is how we attain it from the f of x graph. We keep the graph for f of x greater than 0. So that means here, this bit's greater than equal to 0, this bit's greater than equal to 0. The rest isn't. So the rest of it, we can't use the rest of it. So we'll get rid of those highlights. So they're the bits I just highlighted are the only bits we're gonna keep. Actually, let's maybe highlight it. Is there a lot? Let's maybe pick this gray. So we'll go keep that. So this bit here we get to keep, and this bit here we get to keep. The rest of it has to be disregarded. So reflect the graph in the x-axis. So what that means here is we go down to just below -2 here. That means I would have to go up to probably about, I think it's going to be about here. And we would see this curve goes up and back down here. This bit would be disregarded. Now, I'm not going to scribble that out because it's part of f of x, but it's not part of our function there. So I'm just going to label this with y, this bit here with y equals absolute value of f of x. So we've got that there, and then this bit here is negative, so I would have to change that, and this would come off like this. Now, my drawing is, I'm on an iPad, so it's not the best, but you've got to remember that this bit here has no negative values. Everything is positive in that. Now, I didn't talk about the invariant points, so points on the x-axis are invariant, which means this value, and this value don't change under that transformation for that one. And then points on the y-axis for the first one were invariant, so let me change back to blue. So that means that this point here was the only one on the y-axis, that was our invariant point. So maybe I should put that there, invariant, and these two invariant for that transformation. I'll just, actually no, I'll just get rid of this bit, just to make it a bit cleaner. Too easy. Thanks guys.